pleased to introduce Keith Masback, a friend of the conference, was with us at the start of the first inaugural GeoIgnite. Keith is just a giant of industry. He's the former president for over a decade of the United States Geospatial Intelligence Foundation. He's an investor now, runs Plum Consulting. Keith, I know we're lucky to have Dr. Marshall Shepard here with us. I'm going to turn it over to you.
Thanks so much, John. Just congratulations on the continuation of a fantastic event. It's exciting to see how it grows year after year. The importance for what you're doing for Canada and beyond is obvious, because people are voting with their feet and their time. So appreciate that. We have a unique opportunity today to speak with Dr. Marshall Shepard, the Georgia Athletic Association Distinguished Professor at the University of Georgia and Director of the Atmospheric Science Program. Marshall, welcome.
Thank you for having me. It's an honor to be here.
Well, thank you for making time. I think what to me is most remarkable about all your accomplishments is that you have taken your study of this topic and you have turned it into a storytelling art, because people who toil away and study about things but who aren't able to share them, right, work sometimes in obscurity, and you're able to create a very compelling narrative, and that's as I think about what your work is, to me anyway, that's what stands out. You know, we are speaking here, you sit in the Department of Geography, we are sitting here talking to many people in the geospatial business today. How should geospatial people be thinking about how weather and climate and geospatial come together?
Well, it's an important point. I will say that before I joined the faculty at the University of Georgia, I spent 12 years of my career at NASA Goddard Space Flight Center. So I was involved in these large space-borne satellite missions like the Tropical Rainfall Measuring Mission or the Global Precipitation Measurement Mission, where I served as deputy project scientist. And when an opportunity presented itself to join the faculty at the University of Georgia, my degrees are actually in physical meteorology from Florida State University. I'm a card-carrying atmospheric scientist, but the work that I was doing increasingly intersected with geographical thought, geospatial perspective, equity, risk, vulnerability. So I wasn't just studying hurricanes anymore, or floods, or heat waves. I was thinking about how these things related spatially. And so I am very strong allies with this community. I'm a good close colleague with Dr. Dawn Wright, the chief scientist at Esri here in the US. We had her here visiting because we understand that conveying this information to policymakers, to stakeholders and practitioners is critical. It's not just important, it's critical. I think back to my time at NASA, we would put data formats out there from these satellites in HDF and NetCDF formats, but then I would host workshops with water resources managers and flood professionals, say, we don't need that. We want data in shape files. We want it in things that we can use and manipulate to make decisions on. So one of the really things that I saw early on at NASA is there was a disconnect between what science organizations were providing and what the user community actually wanted.
Yeah, so I think, good job, Marshall. You've got this audience at hello, I think, at this point. As we think about this, and I do think there is a disconnect sometimes between the geospatial community and what's going on around us. I know that what has brought the two of us together professionally is this idea of weather intelligence. Can we be acting instead of reacting? So often it's about, well, the wildfire is here or the flood has happened here. What might this community be doing in conjunction with the broader context you articulated, be doing to anticipate, to be out ahead of these natural disasters?
Well, one of the things that's really taking fire here in the university and across our weather and climate community in general as artificial intelligence and machine learning. I'm a senior contributor to Forbes magazine. And by the way, if you're listening or on the conference, I invite you to follow me on Twitter at Dr. Shepard 2013, because I share a lot of this information in that space at Dr. Shepard 2013. I share a lot of this information, and I wrote something in Forbes last year saying, what is the great new advance, at least in the atmospheric sciences community? And one of the things that many of the people that I talked to came back within the atmospheric sciences community and said is, manipulation of data, data analytics, artificial intelligence. Much of this community and this audience has been thinking about these things for quite some time. In my community, the atmospheric sciences or weather and climate community, it's a relatively new foray. We often will spend our time trying to get the next great instrument, whether it's a spaceborne radar or a passive microwave radiometer or a dual polarimetric ground-based radar, or we'll be trying to tinker and get the next best weather or climate model. I think we're at a point where we have pretty good technology, but now we have so much data. How do we make sense of, detect patterns in, understand the tendencies in data? I just published with one of my doctoral students here at the University of Georgia a paper looking at how we could use machine learning techniques to assess future environments that may involve intensification of hurricanes once they move over land, something that we've called the brown ocean effect in some of our research. And so there are multiple pathways that we can anticipate and predict what we know is going to happen in the atmosphere, because we have pretty decent understanding of it now. Now we have to kind of mine the data, extract, optimize the data in order to make use of it for decision making. I think back to my master's thesis at Florida State. I used the genetic algorithm. We had some of the first Doppler radar data that the National Weather Service here in the US provided. And we were trying to detect patterns in radar to predict where the hurricane was going to move and make landfall. And at that time, I thought, what in the world is a genetic algorithm? But now I understand then that was really sort of a precursor. That was late 80s, early 90s, a precursor to sort of where we are.
Yeah, again, you've adeptly touched on a significant issue for this community, which is a riches as it relates to data, with increasing commercial remote sensing capability, right, awash in pixels, darkening the sky with new systems across multiple phenomenologies. As you think about this thesis or work that you just collaborated on, I think many of us are trying to sort out what do the humans do well, right? What do the machines do well? And perhaps this panacea of thinking that somehow we're going to train the machines to do it all is starting. We're starting to see some cracks there. What are your thoughts?
Yeah, as you were saying that, one of my favorite groups, and I'm sure many of you perhaps are of my age, I love the group Duran Duran, and they have a song on a previous album called "Blame the Machines," and it's a really interesting song, by the way. It's actually, I think it's about BMWs, believe it or not, if you listen to the lyrics. But anyhow, one of the things that I often get, in the show Weather Geeks that I hosted for the Weather Channel for many years, I'd have guests on, and people would say, well, are weather forecasters, of the human element of weather forecasting, going to be completely replaced by algorithms and by machine learning and artificial intelligence? And the answer that I would give to that is unequivocally no. We know that humans, we are limited in our capacity to analyze and mine the vast amount of data that's now coming in from satellite systems, from radar systems, from the various models, whether it's the Canadian model or the US model or the European model. There's too much data for our sort of finite minds to deal with. And so that's where the algorithmic and machine learning and artificial intelligence and geospatial analysis come in. But at the end of the day, in weather and climate, there are still nuances that I don't believe the machine algorithms will ever detect in terms of forecasting certain things about rapid intensification in hurricanes, or why the remnants of Hurricane Ida dumped 3 inches of rain in an hour on Central Park in New York. There's still a place for the human part of the decision-making and detectability equation that we need for risk and uncertainty in our field. I will say, however, in my program, I'm in a geography department, but I'm also the director of our atmospheric sciences program. We actually tell our students, you need to know the atmospheric sciences, the physics and so forth, but if you don't take courses or have some expertise in data analytics or GIS programming or Python, you're going to be lost in this job market going forward. So we are producing hybrid students now.
Well, and as someone who lives proximate to New York City, I got my introduction to immersion pumps during Hurricane Ida, so I very much identify with that.
Yeah.
The nature of that rain event and how few people really understand what it meant when it got into up from the Gulf and into an area of dense population.
Could I let me just say a little bit about that, because there are elements of this that I think are very relevant to this community. So the Hurricane Ida, it made landfall in the Gulf of Mexico and did what landfalling hurricanes do. But the climate change element, and I was listening to the previous speaker, one of the things that we have as climate scientists have long warned about is this idea of as our climate system warms, the atmosphere has capacity for more water vapor availability within it. It's the same thing we experience in the summertime. And your summers aren't nearly in Canada, the same as my summers here in Georgia. But in the summertime, it's more humid because of a basic physics relationship called the Clausius-Clapeyron relationship. The atmosphere has more water vapor. So as our climate system is warming, these storm systems are tapping in the more available water vapor. And so we get these massive deluges, 3 inches per hour, even some of the blizzards. It's counterintuitive, but some of the big snowstorms are tapping into more water vapor in the atmosphere. And so this is very consistent with what we've warned about for decades. But here's the other part of that. Big floods like that aren't just a function of what's falling from the sky. It's a function of what's falling from the sky. It's a function of land cover, because we now have so much more impervious surface on the land cover. We don't get as much infiltration into the soil. We get more rapid runoff in conveyance into the lakes and streams, and then we get more rapid flooding. And many of our stormwater management and engineered systems in cities, whether you're in Toronto, Ottawa, Atlanta, or New York City, are designed for last century's rainstorms. And so that's why they're being overwhelmed. And this is where we need the geospatial thinking of this community to help us understand how we reimagine, rethink the design of cities, the design of stormwater conveyance systems, and so forth.
So I appreciate you taking that up. And one of the things I'd like to tap into your expertise is, so my youngest is an international relations major, and I too said, look, you got to get some data science exposure. You got to learn some coding. That's data analytics. That's just really what got to be part and parcel of any future professional path. When she's also taking her first GIS class, which will be officially one more than I ever took. So she'll be the,
me too, by the way.
she'll be the geospatial person in the family. But when people ask our community, well, how do I get smarter? You go, well, maybe do something on remote sensing or take a basic GIS class. For this community, for a community that is all about geospatial, how do they get smarter about the atmosphere and climate, Marshall?
Well, I'd answer that question a couple of ways. I think a good basic understanding of atmospheric processes is never a bad thing. I find that there are a lot of misconceptions and misunderstandings about weather and climate. And so it leads to things like when it snows, people tweeting me and saying, hey, Dr. Shepard, I've got 20 inches of global warming in my yard. What are you guys talking about? That's just ridiculous. That just illustrates that person that doesn't understand the difference between weather and climate. I often say weather is your mood and climate is your personality, because today's weather doesn't tell me about climate change, nor does your mood tell me about your overall personality. So anytime we can up climate literacy through basic understanding of earth science and atmospheric sciences, I think there's some wonderful websites of the climate.gov page that NOAA has here, the Earth Observatory page that NASA puts out. There's some really nice online products through the Carleton College that I often recommend, and also through the UCAR Comet modules. I highly recommend those, by the way. The University Corporation for Atmospheric Research, or UCAR, has these online modules that you can kind of self-train yourself in areas of meteorology and climate. So I highly recommend those. So that's part one to that answer. But I think part two for your community and mine, increasingly, we've got to understand the societal side of science, how people consume information that you're putting out in your geospatial maps, the colors, the shapes, the messaging, the psychology. That's where the next great advance in weather forecasting is going to be, in my opinion. It's not going to be from the next great model or satellite. It's going to be from this convergence of atmospheric sciences and social sciences that we're now seeing, because we know now, for example, that there's studies that show when we put out tornado warnings on these maps with counties, there was a study out of the University of Alabama that said, I think more than 50% of the people can't recognize their county on a map. Even though we all are very sort of map attentive and geospatially attentive, you're saying there's a tornado polygon warning over Crisp County in Georgia, but if you can't find that warning wasn't any good to the person in Crisp County. And so we have to be aware of these kind of perception, communication, and social sciences aspect of our atmospheric sciences, but also even some of our geospatial techniques. I mean, maybe red doesn't work for some people, or maybe, I'm sure these are things that are thought about in this community, but I think there is certainly a role for thinking about those types of consumption of what you're producing from a social sciences perspective. And then the third thing I would say is keep in mind, we're dealing with a system of weather and climate that has inequitable impacts on communities. There are poor communities, elderly communities, communities of color, and so forth that are particularly vulnerable to some of these things. And so we need to be attuned to that when we're thinking about even our geospatial and atmospheric sciences techniques.
Yeah, that's just so important. I think what you've inspired me today, and I'll take the action to follow up with you. Maybe we ought to find a time, a venue to get more geographers and weather folks together and talk about some of these issues. Collectively.
I think the AAG and AMS have been trying to kind of come together more, but I still would like to see more of it. I mean, again, my home community is the American Meteorological Society, where I was president in 2013, but I am a member of the AAG. I think I renewed my dues recently, but if I haven't, I better do that. But yeah, I think there are opportunities within these professional societies, but as you know, Keith, and as you know, there is increasingly more sort of influence and participation of the private sector, NGOs, and so forth. So it's not just an academic domain. It's not just one or two companies in the private sector domain. There are a lot of new players in both of our spaces now. And so we need to kind of nurture that.
Well, certainly, I mean, if you and Don just put a modicum of attention to this, I don't think there's no force that I'm aware of, not that I'm an expert in physics, that could stop the two of you. So that would certainly be something to be reckoned with. I guess as we wrap up, I want to come back to this idea of can we really get out ahead of it? Can we act instead of react? Is there an ability to have enough, be knowledge empowered enough to the point that these things that seem beyond comprehension in some ways, can we really get our arms around it? Can we really prepare smartly, or are we just so better informed victims?
No, I think as I told someone recently, we've got to move the climate narrative beyond gloom and doom, or, oh my God, it's the warmest summer ever. That's not breaking news anymore. This is the reality of the climate system we're in. And again, to a point that I think that previous speaker articulated well, there are people that believe in climate change and don't believe in climate change. I don't like to frame it that way, because that's like saying, do you believe in gravity? If I go up to the top of this building I'm sitting in and jump off, I'm going to fall. So it's not a belief system, and climate is not a belief system, it's science. And so we know the solutions. We've got to adapt some mitigation strategies that reduce CO2 emissions. And there's technology that will help us do that. In some cases, we're going to have to adopt adaptation strategies. Seawalls will have to be needed in some place, and we have to use drought-resistant seeding in certain places that are starting to see significant variability in agricultural productivity. Those are more adaptation solutions. We know what we need to do. We just have to act. We need an Apollo or a Manhattan scale project vision, or an Operation Warp Speed, as we saw in this country, to develop vaccines for the pandemic. We need that level of effort on climate change, because unlike a pandemic or hopefully a war that we're now seeing across this Europe, this episodic, climate change is a generational thing starting from this point forward. It's not about the polar bears up there in the northern reaches of Canada, the Arctic, or even 2100. We're experiencing things now. And so we've got to get ahead of it when we can. And that's going to take large scale policy and international cooperation, but we can do it.
So thank you so much for your time today. If you would, as we step away here, just share one more time your Twitter handles and other
Yeah,
places.
I engage very actively in Twitter at Dr. Shepherd 2013. DR is the doctor. I would love to engage. If you have any opportunities for any bright geographic or atmospheric sciences students, we've got some good ones down here at the University of Georgia. Feel free to reach out, and just happy to have you to spend 20 minutes with me today. Thank you for welcoming me to your meeting.
Thanks so much again, Marshall, and John, back to you.
Great. Thank you so much, Dr. Marshall Shepherd. Fantastic talk. Thank you, Keith. Keith, I was wondering, did you want to do a little bit of reaction?
I'd be happy to talk about it. Look,
Yeah.
Again, as I said during my brief introduction of Marshall, just a superb storyteller, and we just got just a tease there of his ability to put all this together, and how he has thought about this, and the people with whom he works, and the students he's producing out of his program and others like it. The dialogue that has to occur between us as geospatial practitioners and people who are doing what Marshall's doing. If you don't come out of that talk feeling inspired, then I don't know what else would, right?
He is a great communicator. He put some things like about mood and personality, describing weather and climate, the way he framed it. Yeah, put some pieces together. Great way of explaining it as well. His, most of us have taken a lot of geography in the audience, myself included, but he mentioned about the amount of water in the atmosphere, and that the climate change and these weather events are tapping into that amount of water. Was really, really interesting. He also mentioned something called Weather Geeks. Do you know anything about that, what he's got going on? Because we'd like, certainly, I think people are going to want to hear more from him.
I think it's something that he hosted on the Weather Channel. I apologize, I don't know if it's still running. The Weather Channel does a number of things. Some of it are just clearly mostly focused on entertainment, but there are some parts of what they do which really do drive home deeper thinking about things than just what's today's weather or what's going on with this impending storm. And I think there's content they have. Some of the other content to which Marshall referred would be interesting. In that regard, I'm thinking about another event with which you're engaged, thinking about underground infrastructure. The dirty little not secret in our community is we don't have a handle on what's going on underground. And you better believe that as we deal with increased precipitation and in general, but during these very dynamic events, that the underground infrastructure is going to be stressed in ways we haven't thought about, right? As Marshall pointed out, the underground infrastructure in terms of moving water away was sized for a climate and conditions that no longer exist. And so as we think about not being able to articulate and define our underground infrastructure as is, now we're going to put it under unique stresses, and that ought to be cause for concern for all of us.
Thanks for that. Yeah, that's a great way for me to help promote some SF that we put together with Jeff Zeiss. That's coming up March 22nd and 23rd. It's going to be a similar format to this, and it's all about underground infrastructure, utilities, mapping that. It is a huge issue globally. It is a global get together online of leaders in that community. So thanks for mentioning that.